Hi everyone, this is Bob the Science Guy. We're getting ready to start Chapter 2, which is going to be working on vectors. So I thought it would be nice to just do a quick review of trigonometry for those that hate math. So let's go ahead and just jump right into it. Okay, trigonometry, especially at the beginning part here, is going to primarily just involve the study of right angles. So I want to show you two angles that everybody should really know and really know well. So here are two right angles. Now, this is 45 degrees. That's 30 degrees. These are right angles. Okay? We're going to start off by saying that the length of those sides is 1. And on this one, we're going to say the length is 1 and 2. Now, a couple of formulas that you need to be aware of. First of all, one, Pythagoras. Okay, c squared equals a squared plus b squared. This is how you find the length of sides. The other one is that the sum of the internal angles of a Euclidean or a two-dimensional triangle. If we have 90 degrees here and 30 degrees here, per this second rule, we can tell that that is going to be a 60-degree angle. Likewise, if that's 90 degrees and that's 45, to get to 180, that has to be 45 as well. Now, how do we name triangles? Triangles are named by a convention. So, the largest angle, or the right angle, is capital C. And then you can use whatever other capital letters, A or B, you want for the other two. So, I mean, it doesn't make any difference if you flip them back and forth. Now, the sides are named with lowercase letters, and they are named for the angle they are opposite. So here is angle C, so that is side C, lowercase. Here is angle B, this is side B. There's angle A, that's side A. Let's look at the basic trigonometric functions. There are really only three that you need to worry about for right now. The first one is called sine. Now, the sine, side opposite over the hypotenuse. So, if this is our angle here, the sine of that angle would be this side over that side. Likewise, the cosine equals the adjacent over the hypotenuse. So the adjacent over the hypotenuse. The easiest way that I remember this, and I don't use SOHCAHTOA or any of the mnemonics that you may have remembered from high school, I just say that you can see the sine from the angle, and you're cohabitate with a cosine. Okay? The last major trig function that you have is called tangent. And that is the sine over the cosine. And that would equal A over B. So the opposite over the adjacent. How do I write B over B there? A over B. Let's try that again. All right. Now, let's go back up to these triangles right here. Now, I heard the other day that somebody basically said that in order to get a sine, you needed to use a calculator. You really don't. There are basic signs that you can remember. Now, all of us have seen the table where they take 0 and 30 and 45 and 60 and 90, and then they write sine here, and they write cosine, and maybe even tangent. All right, you don't need to do that. All you need to do is know these triangles right here. Okay? So, let's look at this triangle. Now, our first rule right here is the Pythagorean theorem. So, if c squared equals a squared plus b squared, what's c squared? Well, 1 squared is 1, plus 1 squared is 2. So 2 is the square of the hypotenuse here. So it's obviously the square root of 2. So now we know the lengths of all three sides of this. So let's go down here to 45 degrees for a second. Now, what would the sine of 45 be? Well, it would be 1 over the square root of 2. But it's sloppy to put a radical like that in the denominator, so we'll multiply the top and the bottom. Here, we'll go ahead and do it right here. So 1 over the square root of 2 equals square root of 2 over 2. And all we do is we multiply the top and the bottom. And all we're doing here is we're multiplying the top and the bottom by square root of 2. So now we have square root of 2 on top and we have 2 on the bottom. Likewise, the cosine is going to be 1 over the square root of 2. So that's also square root of 2 over 2. Okay? I never could remember all these things. Now, the other thing is 90 degrees. If you're at 90 degrees, okay, you're all sine and no cosine. So your sine is 1 and your cosine is 0. Likewise, if you're at 0 degrees on any right triangle, okay, you're all cosine and no sine. So we'll go ahead and put that in. Okay? And what about this 30-60 degree triangle? What about this 30-60-90 triangle? Okay. Well, if the opposite side here is 1 and the hypotenuse is 2, what's that? Well, that would be 2 squared minus 1 squared equals that squared. 2 squared is 4, 1 squared is 1. So that is the square root of 3. Okay? So now we've got the rest of our table done. So if we look at 30 degrees, what's the sine of 30 degrees? Well, it's 1 over 2. So we'll put in 1 over 2 there. What's the cosine of 30 degrees? Well, it's square root of 3 over 2. Square root of 3 over 2. Right there. Okay? How about 60 degrees over here? Okay? Well, if we're looking at this angle, up here, what's the sine of that angle? Well, you kind of turn it sideways right there, you can see it. So here's our angle. The sine is that side over that. So it'd be square root of 3 over 2. Notice that those two are interchangeable. So what do you think the other one's going to be? It's going to be the adjacent over 2. The cosine will be 1 over 2. And notice that that is the same there. Okay? Now, 2 more quick things, and then I'll let you go. All right. The cosine of any angle theta equals the sine of 90 minus theta. Okay? Likewise, the sine of theta equals the cosine of 90 minus theta. And we just saw that right here. So the sine of 60 degrees equals the cosine of 90 minus 60 degrees, or 30 degrees. Likewise, the cosine of 60 degrees equals the sine of 90 minus 60 degrees. Okay? That's just a trigonometric identity. Now, why is this important? Sine and cosine are not there just for you to memorize. Sine and cosine are there to be used. Okay? So say you have a vector going out here. And it goes out to a point 3, 2. Okay? So that is this point right here, and vectors start at the origin. Okay? How do we figure out if this is a magnitude of 10 newtons? We have to figure out these two things. How much of that 10 newtons is directed in this direction, and how much in that direction? Okay, well, we can find that out rather easily. So here's our angle. We're going to say that's 30 degrees. Okay? So sine of 30 degrees equals what? Fy over 10 newtons. Does that make sense? So the sine of 30 degrees is whatever Fy is out here over 10 newtons. Now, if we want to solve for Fy, all we have to do is say 10 newtons times sine 30 equals Fy. And that tells us what that is. Likewise, 10 newtons times cosine 30 equals Fx. That's how we find this force right here. Okay? That's just a little bit of algebraic manipulation. We just multiply both sides by the 10 newtons and we isolate the quantity we're looking for. Now there's one last thing that we can do. Suppose they don't give us the angle, but they do give us this point, 5, 4. Okay? What does that mean? Well, that means that we've gone out 5, and it means that we've gone up 4. And it means the tangent of this angle, we'll call that angle theta, equals 4 divided by 5. So what you would do on your calculator, let me show you. So let's clear this. Now, if we take 4 and divide it by 5, that is the tangent. That's the tangent of some angle. However, if we hit second and then hit arctangent, that'll tell us what the angle is. I messed that up because why does this read 0.6747? Any idea? Is that degrees? So let's try that one more time. So we hit second tangent, 0.8. That's 38.66 degrees. We'll do this some more when we do vectors. I just wanted to give a real quick review of this. So that's pretty much all you need to know about trigonometry, at least at this point in the game. Pretty straightforward stuff. The key to it is identify your opposite and adjacent side. Remember, you can see the sine and you cohabitate or are co-located with the cosine. And the tangent is the sine over the cosine, opposite over adjacent. Oh, probably one more thing we should mention. I used a term a minute ago, complementary angle. I want to make sure that we do that, okay? So if you look at two angles, okay, this is a 90-degree angle right here, and you look at this angle, alpha, and that angle, beta. If you add alpha and beta together, they come up to 90 degrees. Beta is the complementary angle of alpha. Alpha is the complementary angle of beta. So complementary means that the two angles add up to 90 degrees. Okay? A supplementary angle is seen here. So this angle right here we'll call alpha, and this angle we'll call beta. Now, alpha and beta, 180 degrees. So alpha plus beta equals 180. Just remember, complementary, corner. Supplementary, straight. Hopefully that helped out a little bit and showed you where sines and cosines and tangents came from and how to use them in practical applications. We'll talk about it more when we talk about vectors. Take care, guys.